Lesson 1.3 has us modeling linear equations with word problems. In this lesson, we'll write and use mathematical models, and we'll use common formulas to solve real-world problems. To model linear functions is the process of translating phrases or sentences into algebraic expressions. So this is just simply called modeling. There are key phrases or words that describe the type of operation you would want to use to set up an expression or an equation. Words like a sum, plus, increased by, more than, total of would indicate addition. As you look through, there are terms that would indicate subtraction, multiplication, division, or setting up an equal sign with an equation. The examples on the right convert each verbal description to an algebraic expression or equation. So we're looking for some of these key words. In that first example, it says the sum of 5 and x, which just means we're going to add them together. If we write out 5 plus x, they're not like terms, which means we'll leave them in that form. Another example, the difference of 4 and b. We would subtract from left to right, and that would be 4 minus b. Look at the wording of the next one. The way it's worded will indicate a different order. 8 less than m, which means m would have to go first. Less than meaning subtract. That is 8 less than the value of m. 3% of t, if we think of 3%, in an equation or an expression, we would convert that to a decimal form. 0.03, you're dividing by 100. The word of is going to indicate multiplication. So 3% of t is 0.03 times t. The ratio of x to 7, ratio meaning division or fraction, of x to 7 is x divided by 7. One more at the bottom here. The sale price is $10 less than the list price. So is going to indicate an equality or equation. Whatever's on the left side will be on one side of the equation. Whatever's on the right side of the is will be on the other. The sale price S, so now we have that as our variable, is would be equals 10 less than, which means we'll subtract, the list price, L minus 10, setting up an equality from that given information. Let's practice a few more. The difference of two natural consecutive numbers. Natural numbers meaning non-fractions, consecutive meaning in order. Difference, we're going to subtract. That would be n minus n plus 1. Consecutive meaning one after the other. The total cost of producing n number of toys if the fixed cost is $500 and each toy costs $5.99 to make. So now we have to kind of figure out what we want our variables to be. We want the total cost, and we have number of toys produced. So I'll do C for total cost, and I'm going to set that equal to, kind of using the rest of the information on the right to generate a formula. The fixed cost is $500. That means just to get started, we have to spend that much money. And then it says each toy costs an additional $5.99 to make. If there are n number of toys, we have to add that to the cost, 5.99 times n. That would be the total cost of production. One more, the travel time for an airplane traveling at a rate of r miles per hour for 900 miles. We now have to think about a formula we may have learned talking about distance and rate and time. How many of you remember the formula distance equals rate times time? That would be the template to follow, so let's plug in what we know. We're trying to find the travel time, which means we'd want to get the rate on the other side. So then time would be distance over rate. Looking at the rest of the information, time we don't know, rate we don't know, but we do know that distance. The distance is 900 miles. Finally, we can clean this up to evaluate the time if our trip is 900 miles divided by various rates. And now what you've all been waiting for, creating a model and solving. Everything here will be word problems. Oh boy. When solving, it's possible you may need to draw a picture, but not every time. So you'll either create an equation or an expression and then solve. Let's take a look at our first example. You accept a job with an annual income of $32,300. This includes your salary and a bonus at the year end of $500. If you're paid twice a month, what is your gross pay for each paycheck? So as we think about this, you get paid twice a month, so how many paychecks would you have in 1 year? So your number of paychecks would be 24. 2 times 12. We don't know how much each paycheck is, so we'll say X is the amount of your paycheck. 24 times X should then be how much you get paid throughout the year. However, we need to think about what your salary is. So if I look at the fact that you have $32,300, that's your annual income. That includes your salary and a year-end bonus. So that bonus isn't on your paycheck. That means we need to subtract it out. So that would be what you make in all of your paychecks. If there are 24 paychecks, how can we figure out how much each is worth? We would just divide by 24. So think order of operations, 32,300 minus 500 is 31,800. And if we divide that by 24, we're going to get a paycheck with a gross value of $1,325. That would be your gross pay before taxes each paycheck. Now we'll finish the rest of the practice problems tomorrow.